Great question here. Each interior angle of a regular polygon with n sides is 3/4 of each interior angle of a second regular polygon with m sides. How many pairs of positive integers n and m are there? Now, not a bad shout is just to start writing down some interior angles. So for an equilateral triangle, it's 60, then for a square, 90, then it's 108 for a pentagon. It depends how well you know your interior angles. I wouldn't spend a long time calculating them. A hexagon's 120. Then 7 is a very awkward number, so I'm just going to skip that one. 8 is 135. And actually, I've already seen that 90 is 3/4 of 120. So I've got n equal to 4 and m equal to 6 as a solution. Then I could keep going. For 9, it's 140. For 10, it's 144. And it's going to be a little bit harder to spot at this point which one's the 3/4. I didn't spot this one, but actually 108 is 3/4 of 144. So m equals 10 and n equals 5 is also a solution. But it's just whether there's any others, like, this is not sufficient to be able to make the proof. We've got to, oh, well, maybe it would be, I suppose, but it's going to take quite a long time to find all of them, especially because the last one, M, is pretty big. So it's not the way to go, but it's definitely the way to go mathematically when you're starting a problem out, because later on I'm expecting to get these as answers. Let's draw a little sketch of the two polygons. Now they carry on, so I can just do dots from then on. And then my second one. Okay. And there's two approaches to find an interior angle. You could either work out the exterior angle and then do 180 minus, or we could do the number of sides minus 2 times 180 over n. Now, I'm actually going to go with the former. So let's go with n minus 2 times 180 over n. And over here, m minus 2 times 180 over n. And I can straight away write down an equation. N minus 2, 180 lots over n is equal to 3/4 of 180 m minus 2. Sorry, that was meant to be an m. Apologies. M minus 2 over m. And although exterior angles can often make your life easier, I think this is a really good way to go because you can straight away cancel out the 180. Now I'm going to talk about two ways of dealing with this question. First of all, the way that I did it, which I think is a little, if you haven't seen it before, you probably wouldn't ever think to do it like it, but it's good to learn the method. So I'm going to go for it that way, and then I'm going to go for an alternative, which is how in some work solutions I've seen, they actually use that one first. But I'm going to go with like the one that I thought was a bit more natural. I'm going to times through by m, by n, and by 4. So that will give me 4m times n minus 2 equals 3n times m minus 2. And then let's expand the brackets. We've got 4mn minus 8m equals 3nm minus 6m. I know this is looking quite complicated. This is a Diophantine equation. It has two unknowns, but they have to be whole numbers, and there's a really nice way we can deal with it. It's just quite subtle. If you've never seen it before, then you might not have thought to do it. But hey, we're here to learn, and hopefully the ideas you'll take on board today. So we're trying to solve this, but we've got to remember this is we're only looking at integer solutions. Now what we can actually do is factorize this into two brackets. So I'll get m and n, so that one's sorted. And then if I want minus 8m, I'll put a minus 8 there. And then I'll need a plus 6 here. Now I know this isn't going to fully factorize. I'm completely aware of that. I've got an extra minus 48, so I'm going to need to add 48 on to make it all work. But this is okay in the world of Diophantine equations where the answers are integers, because there's only going to be a limited number of pairs that multiply to give minus 48. Whereas when m and n could be anything, there's no chance that it could be an infinite number of answers. But we've set ourselves up well with this here. So let's consider some different values. We've got n minus 8 and m plus 6, and they must multiply together to give minus 48. Remember, I want n and m from it. Now, one of these has to be negative. So there's no way that this could ever be negative. So it's the n minus 8 that must be negative. So I need to look at factors of 48, but which one's, well, minus 48. So I don't know, I'm just going to write all of them down, to be honest. Minus 48, minus 24, and then let's write down the pairs 1 and 2. Then we'd get 3 and minus 16. We'd get 4 and minus 12. Just make sure you don't miss any, basically. No, 5 doesn't go into it, but 6 and minus 8 does. Then 8 and minus 6. Okay, it's now just swapping round. So then we're going to get minus 4 and 12, minus 3 and 16, minus 2, minus 1, and 24 and 48. Now I've written all of the pairs down, but actually a lot of them are going to be redundant because I need, first of all, I need n to be a whole number. Sorry, I need n to be greater or equal to 3 and m to be greater or equal to 3. So that is not going to work here or here or here because I'm adding 8 on and I'm still getting negatives. And even that one's out. Okay, which takes us to these. So now I'm going to get positive values of n. And I could have looked at the n plus 6 as well. So when I'm minus 6, I need it to be greater or equal to 3, and that wouldn't be the case for any of these either. So I'm down to 4, and let's just check, but it looks like there's going to be 4 answers. Let's see if we can find them. So for n, I'm going to add 8 onto each of my values. So I've got 4, 5, 6, 7. So I've managed to find the 4 and the 5 from before, but I've got these extra 2. And then for m, I'm subtracting 6. So I've got 6. That's the one I found before. I've got 10. But then I've got these extra 2. 24 minus 6 gives me 18. 6 and 18 are a pair. And then 48 minus 6 is 42. Okay, we would have to have gone up to 42. That's not an easy one to find just by listing them, which is why that method is not the one to go with. But there we go. We found that there are 4 solutions. Nicely done. Now, here's the second method. I actually don't think it's as good, which is why I didn't go for it first, but it is valid. So back to here, rather than multiplying through by n and m, we're actually going to leave them on the bottom. So then I'm going to get, I will multiply through by 4 though, so I'll get 4n minus 8 over n equals 3m minus 6 over m. And then that will give me 4 minus 8 over n equals 3 minus 6 over m, which means 8 over n minus 6 over m is going to equal 1. And I can actually solve the equation from here, because remember, I know that n and m have to be greater or equal to 3, and also I need n to be less than 8. Because if it was 8, I'd already have 1 here, and then I'm minusing something, so it's definitely going to be less than 1. If I had 9, I'd have something that was less than 1, and then I'm minusing something. So I've managed to look, I can just look at a few different cases. We can look at n equals 3, 4, 5, 6, and 7. And then we're just going to sub in each time and then work out if m is a whole number. Okay, you can see it's not ideal, but look, it's going to work. So let's go with n equals 3. I'm going to get 8 over 3 minus 6 over m equals 3 over 3. So then 6 over m would equal 5 over 3, and m would equal 3/5 of 6, which is not a whole number. So that is not going to give me any values of m. The others will do. Okay, so now for 4, 8 over 4 minus 6 over m equals 4 over 4. So then 6 over m would equal 1. M is going to be 6. I'm going to keep going. 8 over 5 minus 6 over m is going to equal 5 over 5. 6 over m is going to equal 3 over 5. M is 5/3 of 6, which is 10. Eight over 6 minus 6 over m. 6 over m is going to be a third. So m is going to be 18. Six over m is 1 over 7. M ends up being 42. Okay, that's our alternative approach. Good to see both methods. Really powerful method here. I would say become familiar with this, but also the other one is a solid approach as well. Tough question. Very well done on your efforts on this whole challenge.